السيدات والسادة، السلام عليكم ورحمة الله وبركاته. يسرني أن أرحب بكم في الماستر كلاس السادس ضمن مبادرة جاهز. تأتي مبادرة جاهز ضمن توجيهات القيادة الرشيدة بتمكين المواهب الحكومية بمهارات المستقبل وتعزيز قدراتها لمواكبة المتغيرات العالمية المتسارعة والموضوعات الجديدة والناشئة التي ستشكل معالم المستقبل. ويسرنا أن نستضيف الماستر كلاس اليوم السيد براد سميث، نائب رئيس مجلس الإدارة ورئيس شركة مايكروسوفت، ليتكلم عن كشف أسرار الذكاء الاصطناعي التوليدي. Your Excellencies, ladies and gentlemen, it gives me great pleasure to welcome Brad Smith, Vice Chair and President of Microsoft. In today's masterclass, Brad will discuss the very important topic of generative AI and its implications for public policy. Having someone of Brad's caliber and expertise to address us on such an important and timely topic is such a great honor. Brad leads a team of more than 1,900 professionals operating in more than 120 countries. He spearheads Microsoft work on critical issues including cybersecurity, privacy, artificial intelligence, environmental sustainability, among others. Please join me in welcoming Brad Smith. Brad, the floor is yours.
Well, first of all, thank you. The honor is mine, and I so appreciated the opportunity to meet with you and others I know who are part of this meeting. I have to say, my trip to the UAE earlier this year has so far been one of the highlights of my year. I feel that I learned so much, took away so much, and when the request came, would someone from Microsoft present on this, I, as you know, said I would be happy to do that. So let me do that today. I'm going to pull up my slides and share them with all of you. So they're coming up right now. And you all should be able to see that. Is it there for you to see? Yes, okay, good. All right, thank you. Well, what I thought I would do is walk through three topics, a bit about what is GPT and how does it work. And what I find interesting is so far there's not as much in the public domain that gets into certain aspects of how it works. And I think that I hope will be helpful for you. Second, everything that is emerging about what we call responsible AI, how does one do this with appropriate safeguards? And just a little bit at the end about implications for public policy, because I appreciate that that is so important for the work that you all do. But let me start with this slide. It shows the rate of global GDP growth every century going back to the year 1000. And what it shows is that for the first 500 years, GDP basically doubled on a global basis every 100 years. No, I'm sorry, it only grew by 40% every 100 years. It grew very little. And then about 1500, it began to accelerate. The invention that first caused it to accelerate was probably the printing press, which was invented by Gutenberg in the 1440s. And so when we got to the year 1500, we saw the rate of GDP growth begin to take off. It then started to double every 100 years. And then we got to the Industrial Revolution in the 1700s with the steam engine and then electricity. And so then we saw it accelerate twofold every century, fourfold every century, and then the 20th century, where we saw GDP growth accelerate on a global basis 20-fold in 100 years. All of this is really because of technology in the first instance, and then technology diffusion, the adoption of technology on a more global basis in the second. And of course, as you all know, I actually think there's few places in the world where you can see the remarkable world in which we live, the way you can where you live. And I just look at this, and in some ways, I think that if this drawing, obviously a photograph, had been shown to the world, 75 years ago, people would have thought it was in the realm of science fiction. And I think that captures, in some ways, what AI may do for all of us in the next 3 decades. And I think it sort of starts in some ways by asking ourselves, what is this? How should we think about generative AI? And fundamentally, I think about it as two things. It's a tool for critical thinking to help people ask more questions and find more answers at a new level, and to help people express themselves more creatively as well. And within just a few years, even in some ways within the next few months, it will just become part of our lives, and we'll start to take it for granted, the same way we take for granted every single other invention that I've shown you. But just to give you one slice of how I just think it will be part of our lives, especially for people who work in governments, who work in NGOs, who work in companies around the world, I'll show you just a 90-second video that captures one set of features that will be part of Microsoft's products in the coming months. Fundamentally, the ability to turn a Word document into PowerPoint slides using a feature that we call M365 Copilot. So you can see this here.
Everyone has had a moment when they wish that they could turn their proposal into a custom-ready presentation without having to start from scratch. Now you can. Using just your own words, Copilot can translate Word into PowerPoint. Now you have a professional-looking presentation that you can hone and polish. Let's say you want to add a slide. Give Copilot some quick instructions and it immediately generates it for you. There it goes. Copilot doesn't always get everything right, so it's important to verify you are happy with it and make any edits that are needed. So this slide is too wordy. You can ask Copilot to make it more visual, which it does effortlessly. And check this out, Copilot can even animate the slide. It gives it a professional design treatment in a single click. But it doesn't stop there. Copilot automatically generates speaker notes for all your slides. It's not only a time saver, it's helping you be a better presenter.
So in a sense, you see how it becomes part of other services and products that are already part of our daily lives. It becomes, as we like to say, a co-pilot, much more than an autopilot. I do think, and you all, I appreciate, are well ahead, frankly, of most countries and governments in envisioning how it becomes a tutor for a student, a doctor, or a patient's assistant that is on people's phones, in their pockets, on their laptops. And there will be many societal benefits, given the ability for people to talk and converse in a more natural way, the impact on productivity, on healthcare, really on the environment, just understanding and advancing digital transformation in a more fundamental way. It's all based on what's called a large language model, and I'll talk a little bit about that. But I thought first I would ask or answer why. Why did we bet, as we did with OpenAI 4 years ago, on a language model? Well, in a way, it was based on a thought or an insight. It was the sense that the world invented language so that we could understand each other and we could understand the world itself. At a tech company like Microsoft, it was perhaps natural that a CEO like Satya Nadella would have this thought that, in a way, the human brain is our hardware, language is our software, the software that humanity invented so that we could talk to each other and really understand the world. And so the basic sense is, if you could create an AI system that could understand language the way we do, it could especially advance the value and power of this type of technology. Right now, everywhere you go, it feels like GPT is the acronym of 2023. And what I find interesting in part is that people don't necessarily pause and explain, well, what is it? And the G stands for generative. I'll talk a little bit about that, but the ability to generate content. The P stands for pre-trained, the notion that you can create an AI model that is pre-trained on, call it, all of the text, the language content in the world. And because it's been pre-trained, it can do new things faster and more effectively. The T is the computer science term, transformer. It refers to the architecture of a neural network. And fundamentally, at its heart, the architecture is about identifying all of the relationships in our language, in all of our languages, between different words and different concepts. Now, that generative side is something that people are the first to discover. They realize you can put in a query or a prompt or request, and it can generate text, it can generate images and audio, it can do all kinds of things. I think that's easy for people to understand quickly. But what's really interesting, I think, is what's underneath the hood, so to speak. It's really not magic. It's not, a person, even though it seems human in some ways. It's really just a giant math machine. And in some ways, I think that's the easiest way to envision how all of this works. In a sense, think about this screen here. If there's a prompt, if I write in "the sky is," and I ask the computer, the AI system, GPT-4, to tell me what word is most likely to be the next word in that phrase, I'll bet you would look at it, especially if you live in a place like the UAE rather than Seattle, and you'd say, well, the sky is blue. That's the most likely word. And in a sense, a big part of what this system does is understand all of the text in the world and develop a probability. And in a sense, every time you see the phrase "the sky is," the reality is the highest probability is that the next word, in fact, is blue. So how does it do that? Well, in a way, it does it, in a manner that, we've been seeing for some time. Every time you use a phone, whether it's an Android or iOS device, you use other products, including from Microsoft, people have become used to autocorrect and autosuggest, and autosuggest has been doing this for some time. But what GPT-4 does is in a substantially different and more sophisticated way. And this is where it helps to learn a little bit more about how a large language model works. In effect, it looks at all of the words that exist in every language, and it starts with what a computer cannot do. It actually cannot process words. It processes numbers, ones and zeros. So it takes every word and it converts it to numbers. Think of it almost like a code. Those numbers are called tokens, and tokens don't always correspond exactly to each word, but for all practical purposes, just think about every word becoming a token. And then it is able to process millions and even billions of tokens. But it doesn't just scan the internet and identify all of these tokens. What it really does is it looks for all of the relationships between these different words or tokens, between the phrases and how they're used, like "the sky is" and "blue." And it creates parameters. And through those parameters, it starts to understand through math and probability where things most likely fit together. Now, that basic approach was developed about 6 or 7 years ago. And OpenAI did two things in the last 3 years that fundamentally transformed how all of this works. The first, it may be reassuring for many to learn, was to realize that if you just let a computer go to work and just train itself by constantly identifying where all of these words are next to each other and trying to develop parameters, it would get good, but not good enough. And so what OpenAI did was engage in what's called reinforcement learning from human feedback. In effect, what OpenAI did was put together examples of output. So if you put in a phrase like "the sky is," it might have 12 different alternatives. And then they would bring in people and they would ask the people to rate from sort of say 1 to 10, if there were 10 alternatives, what was the best to what was the worst. And it did this over and over again over a number of months. And that's what's called a reward model or a reward system. But what it really is doing is using people and that reinforcement learning from human feedback to accelerate or tune the model itself. And so, interestingly, it was the combination of, call it math by a computer and feedback from humans that made the first big advance in developing the capability that we're experiencing now. But there was something else as well, and that's the impact of scale. And I think people often think that the key to scale is just more and more and more data. That is important. The more data, the more text, the more content, the more sophisticated these models can become. But what matters more than that, actually, is identifying more relationships between all of the words, even in a single data set. In other words, finding more parameters, developing them, and then performing more calculations to build a more sophisticated model and enable people to use a more sophisticated model by engaging, in effect, in more calculations really simultaneously to discern meaning. And what we're now seeing in part is a huge advance from what was GPT-3 to GPT-4. Whereas with GPT-3, when someone asked the model to do something, the model could be used and it could do 2,000 calculations simultaneously to identify among all of the parameters what a likely result was. GPT-4 does not 2,000 calculations, but more than 30,000 calculations. So in a sense, in some ways, this actually speaks to me in a pretty profound way. If you just think about what we look for in human beings, what we think of when we use a word like wisdom, it's not necessarily that people have more knowledge, but they are able to discern more meaning. And in fact, that's what this advance does, with, in effect, the ability to call on more parameters, more connections between concepts, and then more calculations to put that to work to help people address individual requests. Now, what's really happening this year is we're going from what we think of as large language models, just the use of text, to what people are now calling multimodal models, or what in the tech sector people are referring to as foundational models. And this too really just replicates the way we as human beings learn and express ourselves. We don't just walk around and think in words. We see images. We see moving images. We use our ears. We have audio. Well, that is where these models are very rapidly going. The ability to take in text, images, and video, and then respond to a request, say, written in text, and produce an image or produce a video. Of course, that is leading to another explosion, if you will, in the amount of data that can be used to train the model and the number of parameters, the connections between the different data sources. But it is this ability to bring all of this together that is fundamentally enhancing one's opportunity to really understand and interpret images. Here you see on the screen 4 examples using GPT-4, where someone showed the computer an image and asked it a question. Explain why the picture, the photo is funny, or why is the little boy crying? The computer is able to look at the picture, see that he's sitting on the ground, see that there's a scooter there, and that the scooter appears to be broken. So this is where people are now suddenly realizing we can call on these computers and these models to help us understand images and to create them. Now, in a sense, what I also find really interesting is there's a whole technology behind this that makes this ability to analyze data, to create parameters, and to use that model. And it's helpful, I think, to learn a little bit about this as well. And in some ways, I think this is a little easier to grasp, at least in my experience, because whenever one can take something that someone cannot see and turn it into something that one can, it just makes it easier for people to understand it. Well, in this sense, GPT did not come out of the air. It's not just people, talking to each other and performing math calculations. It was built in the United States, in the middle of the country, in Iowa, in this set of buildings. This is what Microsoft first spent $1 billion to construct for OpenAI. And when it went live in 2020, it was considered the 5th most powerful supercomputer in the world. And so let me just talk a little bit about how all of this works, because this is what one fundamentally needs first to build these kinds of models and then to deploy or use them. We think about a technology stack. People who work in the tech sector always gravitate ultimately to talking about the tech stack. And at the bottom is always the foundational hardware. And so underlying all of this new technology is what we think of as sort of the AI supercomputing infrastructure, or as we think about it, an AI supercomputing data center. And at the heart of this, what you see in all of those buildings is an extraordinarily large number of the world's most advanced chips. And fundamentally, there's two kinds of chips that are involved. The first is a central processing unit, a CPU. They're in every computer, whether it's a phone or a laptop or anything you've probably been using for the last couple of decades. But the second, the real key here is the GPU, the graphic processing unit. Now, graphic processing unit was created, as the name implies, to process graphics. And anytime you see people playing a game on a laptop or even on a phone, they're using a GPU. And the interesting thing about a GPU is that it was fundamentally designed to be able to process a large number of mathematical calculations in parallel or simultaneously. Why is that important for gaming? Well, think about what's happening on the screen when you're watching someone play a game. Lots of different things are moving around at the same time, seamlessly. That's all a result of that chip's ability to process so many mathematical calculations. Now think about what I was describing before. The ability to discern meaning among all of these tokens or words and phrases, to be able to process all of those parameters and call on them. That too involves a massive number of mathematical calculations being done simultaneously. So what the tech sector discovered was that these GPUs that had been invented for one purpose, games, were actually fundamental to the development of these larger models. So in this case, as you would imagine, you really want to use the most advanced GPUs in the world. They're typically coming from NVIDIA these days. They're designed by NVIDIA. They're fabricated typically by TSMC. In addition to the CPUs and the GPUs and then the hardware storage that you see in that kind of set of buildings, there is also a network architecture that is extraordinarily important for the development and use of these models. It's got to be able to access data from around the world. It needs to have, therefore, high bandwidth networks, low latency connections. So these really are the most computationally intensive facilities in the world. Given the cost and number of GPUs, they're extraordinarily expensive to build and to operate. They frankly require more electricity than almost any set of buildings that you find anywhere in the world. They're important not just for the development of these models, which happens in one place, but their deployment as well. So as we at Microsoft think about deploying the OpenAI models so that people can use them, part of what we're focused on is then bringing GPUs to different data centers around the world. So that's the underlying foundation for everything. Microsoft then developed customized machine learning acceleration software, basically software that OpenAI could use to train these models. And then you get to what everybody's talking about, the middle of the stack. These are the pre-trained AI models themselves, GPT-3, GPT-4, other models from other people. The key for the use of all software platforms, if you will, is then to open them up to applications. One does that through the next layer in the stack, the API service level. We have an Azure OpenAI API, so that then fundamentally anybody can then use this and put it to work. It's enormously expensive to train the models and to some degree to run the models in these data centers, given the size and massive amount of computations that need to be performed. But at the end of the day, the interesting thing about this is it makes it much less expensive at the top of the stack to create applications and to access the models and use them. So that's what ChatGPT is. When you think about ChatGPT, the application itself is about the simplest application in the world. All it is a very simple interface, so people can pose a question, a query, a prompt, and then it calls on the model running in the data center to do all of the work. The same thing is true of Bing or that M365 Copilot that I showed you before. Now, one of the other questions that I think is interesting to think about, I think especially perhaps for governments, is how does one not only use this in a way that is powerful, but also responsible? And so a whole architecture has emerged around this as well. It really reflects sort of the obvious. If we're going to go not only fast but far, we need to have safeguards, we need to have controls. They need to be developed by companies, and like us, as we create these services, they're actually important for every organization that then deploys AI, that creates an application, and for governments that regulate it as well. Now, we've been working at this at Microsoft for 6 years now, and it started by creating a set of principles. And one of the things that one can do is look around the world. Many, many organizations have created AI principles. I think that's a very good thing. And what to me is very interesting is the similarity between principles by different organizations around the world. You can see the 6 that we have developed at Microsoft. We were one of the first organizations to have principles. And one, of course, then needs to define each of these. But the real, I'll say, almost science in responsible AI from a business science perspective goes to how you turn those principles into action by implementing them. And that fundamentally involves 3 things. The first is the development of a policy, a corporate standard. So what we at Microsoft have done is basically use the same approach for responsible AI as we have for privacy and cybersecurity and digital safety. We've created a corporate-wide standard that prescribes for all of our engineering groups the goals they need to pursue for each of these principles, the engineering requirements, and then the engineering practices they need to follow in order to do this properly. There then is sort of an implementation suite. And as you would imagine, one needs to have training programs. One needs to create tooling. At Microsoft, and I think almost any large diversified technology company, you need to create tooling to automate the processes in order to do them not only efficiently, but consistently and effectively. And then part of what you use that tooling to do is to assist you in testing services to ensure that your standards are being met. This needs to be coupled with an oversight system that monitors the work, that really reports up, in our case, to a committee of our board of directors that engages in auditing and compliance. So there's a whole regime that we call on now for every service that we create, for every advance in the model that we deploy. In a sense, though, one of the conversations that's happening this year, people are asking, well, do you really need to keep going? Why don't you just keep this in the lab until it's really, quote, safe? And the answer in part is, as much as we can do to identify the issues in advance, it's not until you get technology out on the road, this has been the case since the invention of the automobile, that you begin to discover all of the things that can arise when real people start using a product in real life. So there's a real aspect that comes together in terms of how we do this in what I believe is a thoughtful and a responsible way. It starts by getting a team together. We call it a red team. And so when we had the first opportunity to work with what was GPT 3.5 and GPT 4 last year, the team starts to look at the model, starts to think about the uses. I'll take Bing because that's the example I'll use, and start to identify what could go wrong, what kinds of problems might arise. They then start to measure the rate at which those problems occur. So if one is concerned about bias, misidentification, one starts through testing to measure the rate of bias. One then imposes additional steps to mitigate that problem, and then one continues to go through this, identifying additional issues, but in each case continuing to measure and mitigate each one. Now, if you take something like Bing, and I would absolutely encourage you to use it because it will make a lot of this real, there are really a number of different things that come together that are both technical at one level, but just sort of practical at another. It starts with models themselves. When the team within OpenAI is working on the development of a new model, like GPT 3.5 or GPT 4, they have a safety team that does what I just described. They start by identifying in the model itself certain risks, certain problems. They start to measure, they start to mitigate. But that is really the start of this work. It's not the ending. And I think this is where we're all going to find that if you're a government or a company or you name it, you're going to have people that will be trained in this work relating to responsible AI. So when you take something like Bing, a search result, the first thing we do is recognize that the key, in part, to accuracy is to ground the model and the use of it in real search results. So the model has been pre-trained on all of these parameters, but it doesn't actually have current data in it. It just has the parameters that were developed. So that if you go to Bing and you ask it for information, the first thing it does is it pulls data from the internet and our search index that's constantly updated, and then it takes that data and then gives it to the model so that the model can reason over current data. That's the first thing we do. But the next thing is really fundamental to responsible AI. It's, think about it, the architecture, technical architecture that sort of surrounds the model itself. And it fundamentally consists of two things, what we call classifiers and meta prompts. A classifier is really, almost as the name might imply, a class of issues or questions. And one starts to build classes around problems that the red team or others have identified. An obvious one is, well, what if someone asks Bing or ChatGPT to tell it how to build a bomb or how to commit suicide, to do something that we would find problematic, grounded, if you will, in those 6 principles. We build a class of questions, so we're able to, in effect, identify not just one way to phrase that, but many ways, and then we create what are called meta prompts. A prompt is basically what you do when you ask the model to do something. People also refer to it as a query. Well, a meta prompt is a whole class, therefore, or a set of prompts that we want to apply to that class of questions. So in other words, if someone asks, tell me how for help to build a bomb, or how to commit suicide, we will create a meta prompt that in effect will intercept that. And instead of asking the model itself to reason and provide an answer, it will instead provide an answer that we feel is necessary and appropriate. Like, I'm sorry, I will not help you build a bomb. Or, if you are suffering from a mental health challenge, here is where you can go find help. The next thing we then do is we try to build into our services easy ways to guide the user in how to use them through the user interface. So you see here in Bing, there's 3 different modes, from creative to balanced to precise. What we've discovered is that the error rate, the so-called hallucination rate, can be reduced almost to 0 by putting the tool in balanced or precise mode. It won't be as creative, but it eliminates the risk of errors. On the other hand, if one wants to write a poem or engage in creative writing, the model performs better if you instead select the category over on the left. And then finally, while one needs to get this technology out on the road, one doesn't literally want millions or hundreds of millions to all try it on the first day simultaneously. So we control its release. So with Bing, on day 1, it was only available to 2,000 people, and then to 20,000, then to 200,000, then to 2 million, and then more broadly. And I think this is helpful to think about, not just in terms of how you or the government or the people of the United Arab Emirates might use a product from OpenAI or Microsoft, but I think it's actually helpful to think about for the applications that you would create for the government itself. You'll want to have guardrails, and we view part of our role as a company in working with customers and governments and the like in providing the know-how, not just in the technology, but how to build and deploy the technology in a safe and responsible manner. Finally, just very briefly, I'll just offer some concluding thoughts on what I think this means to some degree for society and public policy. In a sense, if you want to accelerate innovation, and I appreciate how important that is in the UAE, one needs to think about the ingredients that accelerate it. It's access to GPUs, that's where I think the conversation between a company like Microsoft and the government in part focuses on how we enable the country to access the technology capacity for these advanced computational models. One needs to have access to data, one needs world-class talent, and then one needs, I think, a supportive policy environment. We've increasingly started to focus on what we see as 6 categories of public policy issues. The first one is the one I've really been spending my time talking about here: responsible AI, safety, security, and the like. But there are these other 5 areas as well. And I think we're going to see very robust conversations. We're going to see a lot of innovation and change. We're going to see new public policies emerge in each and every one of these categories because of AI and to address the uses and implications of AI. I do think that ultimately the societies that get the most value, that put themselves in a leadership role, are going to be those that innovate the most by just putting these services to work. And in a sense, if you go back to that very beginning, the rate of GDP growth, in the world today, unlike the world of the 1700s or the 1500s, it's far easier for any government and any country to actually harness the power of innovation. But I think the key is having it deployed quickly. And you all, I appreciate, are already focused on this, but it's about identifying fast ways to put it to work in education, throughout government services, in healthcare and energy. Just last week, I was in Korea and in Japan. Interestingly, the education minister in Korea is focused on developing 3 digital textbooks that are all AI driven. One will be for math, one will be for learning English, one will be for coding. And so we're starting to see this kind of innovation spread. I have to tell you, I still haven't found anybody that is as advanced as you all are. So I think that's a really interesting signal. And then there are other policies as well. I think a broader skilling effort is going to be critical. We could talk a little bit more about that, as well as one of the topics I talked about when I was in the UAE. How does one ensure that this works really well in Arabic? Interestingly, I had exactly the same conversation last week in Tokyo about how to make it work well in Japanese. And it's really about two things. One is having a large data set so that there is more data over which the model can be trained. And then the second is really to work with a company, I think, like ours and like OpenAI, so that there's the proper prioritization, so that as the models are improved, there is more, frankly, computational work done to reason over the data set in that local language to find all of the various connections and develop the number of parameters needed so that these models work as well in one language and culture as in another. Finally, I'll just note two other areas where I think we're going to spend a lot of time in coming months and years. One is, unfortunately, I think when we look at governments like, say, Russia or Iran or even China, we do see more work by them to use the power of AI to engage in cyber influence operations. So governments are going to need policies to be able to use AI, I think, to detect and defend against these. And then ultimately, there's a huge sustainability issue here, because all of this is based on this enormous amount of computational power that requires enormous amounts of electricity, which has to be built on renewable energy. So all of the data center conversations that we've been having about renewable energy become even more important. It really does require a multi-stakeholder approach, and I'll conclude there. I probably have talked a little bit too long. I apologize. But I think what you hopefully see here is how you start with an understanding of almost the architecture of the models. Think about what it means to create the hardware needed to develop and deploy them, the architecture of responsible AI, and how that connects with public policy. So let me stop there and be happy to address your questions, and I will stop sharing this.
Thank you very much, Brad, for the informative presentation. Amazing what we have just learned. So I have a couple of questions from the audience, and I have to tell you, one question is from ChatGPT, actually. Okay, so the first question, Brad, what's next for ChatGPT and generative AI more broadly? How do you envision GPT AI technology evolving in the future when what we are witnessing today is already mind-boggling?
I think we're fundamentally going to see two types of innovations. The first is the models themselves will continue to get larger and more powerful. So, while I showed you those buildings in Iowa for GPT-3 and GPT-4, we're currently constructing the next phase and be even more powerful data center supercomputing infrastructure in Arizona. And then we're already thinking about the next two generations after that. So we will see the power and capability of the models continue to get stronger. But second, I think where we're really moving is an enormous amount of innovation in the applications layer. That's where what we're going to see every month is really on a global basis, new applications that will harness this power in very creative ways. And if there's one thing that we at Microsoft always say, what really typically excites us, sometimes it concerns us, but mostly it excites us, is the creativity that people bring in finding new ways to put technology to work. And you're just going to see an explosion in that application space.
Thank you, Brad. How do you ensure that GPT models are trained on diverse and representative data sets? And what steps are taken to mitigate potential biases in the resulting models?
It really goes back to two things I've talked about here. The first is to make sure that the model itself is developed or trained with not only a broad data set, but with the right prioritization of, call it, computational energy or resources focused on that data set. And this is where I do think that there will be opportunities around the world. You take a language like Arabic, it's spoken by what I think 319 million or so people around the world. But there are opportunities, I suspect and believe, to identify more Arabic language content, make sure it's available in digital form, make sure it's accessible, meaning it's not behind some firewalls or other places, so that it can be used not just by OpenAI or Microsoft, but by everyone who is developing these models. The second on bias is really good to go back to that architecture I showed you to identify where and how bias can creep in. And I think in part that requires diverse teams in the first place who are sensitive to it. But then it goes back to testing. The reason I'm fundamentally often optimistic about the ability to reduce bias is that fundamentally bias creates errors. And so, software developers look at that and they say, that's a bug, that's not a feature. If it works better for identifying the faces of one gender than another, well, that's a problem, and people go to work. And I just think you're going to see continued focus and advances in reducing bias, using that ability to test the results and then drive the error rate down.
Thank you very much, Brad. This is an interesting session. Unfortunately, we don't have enough time. There are so many questions, but I'll have to conclude it here. Thank you very much for your time. Thank you very much for the amazing information. And I would like to thank all the participants who have attended. Thank you very much, Brad. And thank you, everyone.
Well, thank you. As I said, the honor is mine. I hope this was helpful. You can count on us to provide additional information, and we look forward to working with you all. I look forward to being back in Dubai in conjunction with COP28 later this year.
Looking forward to have you.
Okay, thank you.
Thank you, Brad. Bye.
Bye.